Hello, I'm Nick Paradiso, Product Manager for the Conveying product line for Conair. I'm very excited today to present our RFID proofing technology for our resin selection station product line. How this technology works is as follows. Each physical location on the output matrix of the resin selection station has an RFID antenna that's associated with each physical position. We understand which source is associated with each physical position based on how we plumb the system from material sources going into this resin selection station. Hanging from the ceiling from flex hose have dedicated lines that are run back to each of the receivers that pull from, or I should say pull through the RSS station from the material sources. Each of these has an RFID transmitter that has a unique identification. What we do here is we proof if the correct material change has been made. But Conair is taking this one step forward. We're going to walk the operator through the correct change that needs to be made with LED light indications. Let's walk through how our material change is going to work. What I have here on my iPad is a VNC connection into our SmartFLX central control system. The beauty behind this technology is that this table does not need to be located physically next to or near even your central control system. You can walk away a couple hundred feet away if you have to based on your plant logistics. You can walk away to initiate a material change, and then you can walk up to the station if it's in a remote location. Or for a convenience factor, you can have the SmartFLX remote HMI located somewhere closer to your station if that's of value to you, but it's not required. This is the VNC connection into the SmartFLX. What we do here is I show on the SmartFLX, we show the matrix that we're looking at. I have two connections that are already here. And you can see that these connections on the output matrix are indicated as green, correct, proofed connections. This menu is an interactive menu. I can select anywhere on here and it's going to tell me how many of the like connections are the same source from the connection that I've put on the control. Or, for example, if I connect, right now I've selected this position. I select this position and I see the receiver and the source that's associated with this connection. I can learn what's going on the table, and then now I can initiate my material change. What I do here is if I initiate a material change, I'm going to say I'd like to send receiver 4 and now assign it on the table to source 7, where it's currently assigned to source 4, for example. The receiver name and the source name can be modified to whatever you'd like it to be. In this case, just for this demonstration, we have letters and numbers. I'm now going to assign and initiate that change on the SmartFLX control system. The first indication you're going to see is a blinking yellow light. You see that here on this position. What the blinking yellow light is telling me as the operator, this is the connection that I need to remove from the table to continue on to change it to a new source. When I pull this from the table, now notice all of the possible connections that are associated with physically on the table with the source that I want to send to this destination are going to light up with blue LEDs. I can put this in any of the positions here, but for ease of use, I'm going to put it over here in the front. And now you're going to see it's approved, it's a proper connection, it's a correct connection, and it's going to proof it and give me the immediate indication that this is green, I've made the right connection, I can now move on with another responsibility. Now, what happens if I make an incorrect connection? Let me tell the control, I'm going to initiate this same source and I'm going to move it back to where I just took it from. I've now just initiated this material change in the system. Notice again, I get a yellow LED, it's blinking, it's telling me this is the correct connection to make. I now remove it from the table, and just like we showed before, I have blue LED blinking indications that are telling me where to put the correct connection. And this connection is already green, so that's not blinking, it's already proofed, and it's going to stay green throughout the whole process. What happens if I put it in the wrong connection? I've just put it into the wrong connection, where the whole concept behind proofing is that this happens all the time. I've asked multiple producers, have you ever made the wrong material change, or have you ever sent the wrong material to the wrong machine, or filled the wrong silo with the wrong material? I rarely ever hear the answer is no. This happens all the time, so this technology prevents us from doing so. What this is telling me is, it's giving me a red LED blinking light saying this is the incorrect connection, and while that's blinking red, informing me as the operator that I've made the wrong connection, it's also telling me where the correct connection is to continue on with the process to fix my mistake. What I'm going to do is I'm going to take this out of the table, come over and put it into the correct location. And now you're going to see there's a green LED. I'm now proofed and I'm now ready to go. Throughout this whole material change initiation, that receiver has been locked. When I had it in the wrong connection and throughout the full material change process, that receiver is locked, so I cannot convey the wrong material to the wrong location. The only possibility of this material to convey is once the RFID antenna is looking for that unique identification code. Once we mate that in the control system, we unlock that receiver to be able to be turned on to convey material. Another feature Conair is releasing to the market is our clean cycle port that's associated with our RFID resin selection station. The clean cycle port is an option, and it's going to be used for when there are non-purge sources that are associated with any of the physical locations on the RSS table. When you make a material change with a purge source, at the end of every conveying cycle, that purge valve, the whole purpose of the purge valve is to clean out the line after every conveying cycle. This is typically used in a central drying system where you're spending a lot of time and energy to dry your material and you convey it to the machine. You don't want it to regain moisture in your material handling lines, so we purge those lines out. If I'm making a change from a purge source to another fresh source, that line is already clear after the resin selection station. But what happens if I make a change from a non-purge source? If I'm not purging that line, after every conveying cycle, gravity is going to let all those pellets fall back down that flex hose on a connection that's already on the table and reside down in that common material fantail underneath the table assembly. The problem is when that line elbows and conveys all the way out to your receiver, all those pellets are still in the line there, and that has not been cleaned out yet. With RFID technology, we have this physical location on the clean cycle port. We understand that is there in that physical location, and the control, the smart FLX in this case, is smart enough to understand, am I making a material change from a purge source or a non-purge source? If it's a non-purge source, it's going to walk the operator through the sequence to put the connection in this clean cycle port. It unlocks the receiver. The receiver still has to be cleaned out, and a process or an SOP can be written around going to the receiver and doing a proper material change, a proper clean out. Perhaps that receiver is slid over on the throat of the injection molding machine to a drain port, for example. We run a couple of conveying cycles, and it's going to clean out and purge, quite frankly, that line clean. So when I do initiate and continue that material change to the connection that I need, I now have a clean line that I'm going to be conveying through, and I'm not going to contaminate the first couple shots on the machine. A couple more features to touch base on with Conair's RFID resin selection station technology. First is the RFID by design is wireless. Notice there are no communication or power that's required to come down onto the RFID transmitter. And when you go to make a change, sometimes, especially when these tables get larger and larger, you have to really wrestle the flex hose around, get it into its location. Imagine trying to do this and I have 10, 12 machines pulling from the same station. The beauty behind this design is that this RFID transmitter is floating. It penetrates through this top plate. All of the electronics are protected underneath the table. This RFID transmitter, all it has to do is get close enough to that RFID antenna. There's slots in each of the tops of the table, and this bracket pokes down through the table and makes that connection. When you go to make the connection on the table, there's no more clocking needed, where this is on a floating bracket. You go to make your connection, you could use your other hand, move it over into the location, put it into the table, and you're good to go.